In this video, we will take a look at the graph of the quadratic function. We've seen before how to find roots of a quadratic function or a quadratic equation. And in this video, when we graph it, I'm hoping you will see what they represent visually. So let's get started. When we consider graphing, we do use the general formula of y equals ax squared plus bx plus c, or we might write it in function notation. F of x equals ax squared plus bx plus c. All quadratic functions produce a shape called a parabola. And that is a shape that either opens up like this, having a vertex at the bottom, or it opens downward and having a vertex at the top. All parabolas are symmetrical about a vertical line. All right, so they have the center line and there are equidistant points on the parabola all the way along, okay? So let's get started and see if we can find out what this function looks like as a graph. We'll begin by factoring it and find its roots. So I want to take a look at two numbers whose product is -6 and whose sum is +1. So that will be, let's see, is it 2 and -3? That sum is -1. Is it -2 and +3? That sum is 1. Great, we found it. So that means that it factors into x minus 2, x plus 3, and that is equal to 0. Actually, not equal to 0 yet. Let's explain why we set it equal to 0. That will come from it being in function notation. F of x equals this, okay? So I've just factored that one down. So it's in function notation, f of x. Now, what do we know about values along the x-axis of a graph? In terms of their y is neither positive nor negative, right? So the y values are 0. And that is actually the f of x value. So if we set that equal to 0 and solve, we actually are finding the values of x that have an output of 0. Okay, so we're finding the x-intercepts. So then we called those the roots. So in our last examples and our last videos that we watched, when we found roots, we were actually finding where the parabola crossed the x-axis. And these are significant points because they help us for graphing. So the roots in this case are x minus 2 equals 0 and x plus 3 equals 0. And that means that x equals 2 and x equals -3. Sorry, 2 there, 3. So if I were to begin graphing, I have an x-axis and a y-axis. 1, 2, 3, 1, 2, 3, -3, and 2. This parabola crosses at x equals 2 is a point, and x equals -3 is a point. Now, we're getting there. We don't know whether it's a parabola that does this or whether it's a parabola that does this. Now we need to find out the maximum or minimum point where it has a vertex. So let's take a look at how to do that. So since all parabolas either open up or they open down, they have a minimum point or a maximum point, and in each case we call these the vertex, okay? That one and that one. And the vertex is kind of a center point. It is the parabola is symmetrical on either side of a vertical line that passes through the vertex. As the value of a increases beyond 1, the parabola lengthens or stretches out. Let's see a formula for the vertex. So a vertex can be found, since it's a point, this is the x and this is the f of x, or also known as the x and the y. So the x value is negative b over 2a from the general form of the quadratic function. And the f of x is f of negative b over 2a. The y-intercept will be 0, c. So we should find the vertex for our graph or our function that we just found our roots for, and then we'll know whether this function opens up or opens down, and it will be a third point that we can use to graph our parabola. So by using the formula for vertex, and that is negative b over 2a and f of negative b over 2a, we're looking at the same quadratic function where the a is equal to 1, b is equal to 1, and c is equal to negative 6. When I plug these values into the vertex formula, I get negative b is 1 over 2 times 1, and that will simplify to negative 1/2. Now for the y value, I need to sub in negative 1/2. We need to find f of negative 1/2 in our function. So I'm going right back up to the original function. And I'm going to sub in negative 1/2 everywhere we see x. Negative 1/2 is squared. Plus, we have to add a negative 1/2 and subtract 6. Let's work this through. Negative 1/2 squared is 1/4. And adding a negative half is subtract a half minus 6. All right. We should probably put these all into quarters and then add them up. All right. So in order to add these fractions, we have 1/4 and 1/2 as a quarter is 2/4. And 6 in quarters is 24 quarters. So 1 subtract 2 is negative 1. Subtract 24 is equal to negative 25 quarters. And that's actually negative 6 1/4. Okay, we have the y value, negative 6 1/4. That's the vertex of our function. Now let's graph it. Okay, so I already have a really nice graph of it, but let's just take a look at where each of these values sit on our graph. Okay, we have our roots, x equals negative 3 and x equals 2. So there and there. And at that point, we didn't know whether whether it opened up or down, right? So we find the vertex. And if I plot the vertex, we go over negative 1/2, and this is negative 1 to here. So negative 1/2 is along this green line, and down 6 1/4, which is down here. So our vertex sits right there. And so imagine the red graph is not already there. However, once we know the vertex and we know the roots or where it crosses the x-axis, we can then connect with a nice curvy line, and it goes forever in this direction and connect through that other root and up and forever in this direction. Every parabola has a vertical line down the center that is a line of symmetry through the vertex. And there it is graphed. Okay, so I have one more here. And if you think you can try it, I encourage you to pause the video and try graphing this parabola. Factor first to find the roots, and then use the formula to find the vertex, and plot everything on a little graph. It can just be a sketch too for you to get an idea. Otherwise, I'm going to go through and I'm going to do a solution here. So I have to think of two numbers that multiply to make -15 and add to make 2. So they differ by 2, and that is 5 and 3. However, one of them is negative. So it is -3 and +5. All right, because -3 plus +5 is +2, and when I multiply them, we get -15. So this becomes x minus 3, x plus 5. When we set this equal to 0, because we are finding the roots, right, along the x-axis, the y value is 0 for roots, so we set it equal to 0. And x plus 3, sorry, it's minus 3. Better be careful. X plus 5. Set each one equal to 0. X equals 3 and x equals -5. So let's use a blue dot and put our roots on our graph. 3, so right here is 3. I should mark that line with a 3. And -5. Now, halfway between 3 and -5 is what value? And it is actually at -1, right? Because that's the halfway point. So we do know, before we even find the vertex, that it's the vertical line that passes through the vertex is at x equals -1, because parabolas are symmetrical, right? There's a difference of 4 here, and there's a difference of 4 here. So just another feature of parabolas that I thought I would take this opportunity to point out since we are graphing a parabola. Now let's find the vertex. And the vertex is -b over 2a, f of -b over 2a. So I need to scroll this up here for a moment and get a little space to write in. We'll do that formula. Let's find the x value of the vertex. -b over 2a. So negative, what is b? b is 2 and a is 1. Okay, so -2 over 2 times 1. F of -2 over 2 times 1. Which is equal to -1 f of -1. Okay, the -1 coincides with the x value of -1. So our f of -1 is somewhere along the vertical green line that I dotted. Let's find f of -1. I want to rewrite my function down here. And so f of x equals x squared plus 2x minus 15. Let's just rewrite that. What? No, it wasn't 2x. F of x equals x squared plus 2x minus 15. And we want to find f of negative 1. So we sub in a negative 1 everywhere where there's an x. And we get f of negative 1 is equal to 1 minus 2 minus 15, which is equal to 1 subtract 2, which is negative 1, subtract 15, which is negative 16. So this is way down here. Let's put a red dot at negative 16 right there. So there's our vertex right there, which is negative 1, negative 16. And now we'll graph it by putting a curved line up and through that root, and another one symmetrical to it up and through this root. And there's our graph. Thanks for watching.